Welcome back, everyone. Or welcome to you for the first time if you're watching this video first for some reason. Anyway, I got this new breaker panel in here last night. And I think I'll start off by putting back the refrigerator receptacle, since that'll be a dedicated thing. Let's give ourselves another receptacle to work with real quick. We've got a lot of cordless tools these days, but we still need to plug some things in. So, receptacles are nice. This will give us one in a different room. We'll screw this in this time. Alright, I'll tighten this clamp before I put the second screw in, so it'll quit shifting out of place. And now an adjustment. And difficult to position when the screws are at such a sharp angle. You gotta lead it a little bit. There we go. Here's the kind of thing that you keep all your little wire scraps for. They always get used. I need an extra ground conductor here. In the old days, it was considered good enough that a metal box would become grounded through the frame of the device here, because that's grounded. But that only works when it's screwed in, and that only works when there's good contact. And we're talking about contact between steel here that often gets painted and is galvanized. So, the modern practice is to give the box its own ground conductor that will be wire nutted in with the rest of whatever ground is going on in there, affixed with a proper ground screw, not the wire clamp screw or anything else. Those are not designed to hold a wire very well, and they don't. And that's not a flat surface there that you're putting it on. These ground screws have kind of an enlarged washer-like head there that will keep a wire in place. And pretty much all the metal boxes have threaded holes, usually more than one, for such screws. There are some modern devices that add an extra little metal clip on the mounting point here that's supposed to bite into the mounting screw and is then approved as a means of grounding the box. But let's not assume we're going to have that, and this is better. So the first thing we do when assembling a box is bend a little loop there, tighten it up, and bend it that way, and it makes it easy to install. And we trim the other conductors to length, usually going for about 6 inches from the face of the box. Strip that without cutting into the interior insulation. It's easy to do because you don't have to cut all the way through this for it to tear open. Need another short ground conductor, so we have one for the device, in this case the receptacle. We twist those just to help hold them in place while I install the connector. And the connector winds up twisting the wires just how they should be. There's no need to do that beforehand. And that's another thing. People used to just twist the ground wires together. Now we use connectors. And I screw in the unused screws so they're not sticking out, shorting out on things. Drip the appropriate amount of conductor, which is such that it will wrap around the screw without having any more bare conductor sticking out. So you want to make sure that you don't get insulation wedged under the screw there, interfering with a good connection. And this requires a firm grip with both hands, because you want to get this pretty much as tight as you can without breaking anything. And that way, I've never had anything loosen up on me. Then we pay attention to how the wires are folded, which is totally up to you and depends on the application and what's going on in your box. And same loop for the ground. They have that hole there to aid doing that, but it only works with 14 gauge wire, and I like to always use 12 gauge wire wiring receptacle circuits. As it doesn't cost that much more, it isn't much harder to work with in that application, and it will give you better power, less voltage drop, cooler conductors, and allow you to have acceptable power farther away from the source. And for the same reasons and more, I do not use these push-in holes that are optional on the back of receptacles and switches. One, they normally only work with 14 gauge wire, but then it's not that great of a connection in the first place, and it always loosens up over time. And that's a really annoying fault to chase. Wasting everyone's time there. And then there is the great receptacle orientation debate, which on one hand says that it's safer to put them in this way, because if you have a wire pulling on a plug and it's sagging partially out of the receptacle and you drop something metal down here, that in this case it would hit the ground, whereas the other way it would cause a short across the live and neutral. And well, that's a valid point. I have never seen that sort of thing come close to happening anywhere, and seems to me would be the result of bad planning in the rest of the setup of the room, whether having things falling off your workbench onto your live plugs, or poor choice of location of metal wall decorations. I don't know. But I prefer not to ruin right angle plugs, which are designed to hang down in this orientation. Completely rigid on that. If I noticed an application where that particular safety hazard was likely, I would put them the other way. Generally, I prefer this way. So go ahead and leave your angry comments on that down below. Alright then, time to clean up this mess in the old fuse box before we reconstruct it. So, well, I want to leave these conduits here attached for their historical significance. We don't want some uninformed, unqualified service person of the future trying to attach things to these wires or use the conduits. So, we'll just cut these off flush. It should prevent any of that. That one's not a conduit. It needs to go. And this is the old oven cable, which has to go. Well, it does have a ground, unlike the other cables in this building. It also has the most brittle insulation I've ever seen. And here's why there were almost no neutrals connected in that large panel that I removed yesterday, that they replaced this original one with, is they just connected them all at once with this large conductor, creating an inaccessible connection behind the panel. Okay, Take our refrigerator wire. Install the clamp. Go get a modern clamp. I believe this clamp was meant for armored cable. You look at the way the ridge there is on a slight angle to go with the spiral nature of the jacket of armored cable. And it has this other raised area on the other side. Install your cable appropriate clamp and feed into place. Secure your clamp to the enclosure. With nut provided. And Ed's been away for lunch since I got here, but it appears he already dismantled the wood top of our cutting table because he's done cutting vapor barrier triangles. And I put the wheels back on here, turned it back into a scaffold, and installed a few more triangles with foil tape. And once inside an enclosure, you remove all of the outer insulation so that you can position the individual conductors neatly. Otherwise, it will become a ridiculous mess. And I'll attach this to our temporary circuit for now, since I haven't purchased the breakers for this project yet. So I spent the rest of this afternoon cleaning up this ceiling structure, reinforcing it a bit here, adding some screws wherever there was something to screw to, and making a plan for how I'm going to reinforce this with steel. This steel that I brought yesterday, all the way through into this ceiling in the closet here. And carve some more clearance here in order to structure this the way that I want it. I think I've got a pretty good plan now, and hopefully we'll do some of that tomorrow. And Ed got a bunch of these two-piece triangles assembled with the foil tape. So a bunch of that can go up tomorrow. But for now, I'll remind you that you can donate to the project at fullerdomehome.com, which I will list in the video description. And if you want to follow the project, you can subscribe to my channel and click that bell icon to be notified when new videos go up. Thanks for watching. I'll see you tomorrow.